recording to the cloud. And we are recording. It's another episode of the Ethereum Classic Show. It's been such a long time, guys. I finally have a green room. This green room becomes the Emerald City, the immutable fortress, the Ethereum core, where the law of the land is code and the grass is always greener. I am so super pumped to be back in action doing the Ethereum Classic Show now because of this big new change. We're finally telling people don't mess with ETC because we're going to stop those 51% attacks. Stop those 51% attacks and start building stacks. We've got Isaac, senior developer at ETC Labs, in Austin, CEO of OpenRelay. These are two of the big brains behind the MESS algorithm finality solution. Guys, first of all, this is a big deal, is it not?
It's exciting.
Yep. Yeah, it's a cool solution.
And from what I understand, this will really make a 51% attack almost impossible.
Over a long time scale, that's true. You know, within blockchain networks, there's small reorganizations that happen, and you know, if you wanted to execute a reorganization attack for a couple of minutes, you still could. But the longer you want to make your 51% attack, the more expensive it gets. Okay,
so now what change has happened where the systems, the nodes will be able to understand that, oh, this is a bad reorganization, or how do we understand that now?
So, you know, reorganizations are a natural part of running a blockchain. You have, you know, nodes spread out across the world. They're working on discovering blocks. Sometimes two will find it, or, you know, one node will find a block, another node will find a block before it hears about the first one. And that's just a natural part of the process. And you know, it's built into blockchains to resolve that automatically. But when you have somebody, you know, building blocks and not telling the rest of the network about them, that's when you get into a 51% attack where they, you know, build up blocks for several hours, then dump them on the network to undo a bunch of stuff that the rest of the network has done. So what the big change for MESS is it weights the chain that a node has already been on by an increasing amount over time. So if it sees, if it's been on a block for, you know, 30 seconds and it sees a replacement block, it might go ahead and take that because, you know, 30 seconds is totally within the natural order of reorganizations on a blockchain.
And these happen on any proof of work blocks. So like
absolutely.
Bitcoin has constant
I mean, Bitcoin will see reorganizations, you know, maybe not as frequently because its block times are longer. You know, Ethereum and Ethereum Classic with 15-second block times, they see reorganizations every couple of minutes. But we're talking small, like 1 block reorganizations,
right.
Not you know, 3,000 block reorganizations like we've seen with some of the 51% attacks.
Okay, so what happens now is if there's a very large reorganization, that it becomes just harder for that to get pushed through to the network.
Right. So yeah, at that point, if a node sees, you know, a reorganization off of a chain that, you know, diverged from the chain it's on several hours ago, it's going to say, okay, you don't just need to be you know, as strong as my chain, you need to be 5 times stronger than my chain, because you're coming at me 5 hours later, you know, or several hours later than
it looks unnatural. It wasn't part of the, you know, the regular kind of information I'm seeing. The node's not seeing something that's a little out of the ordinary. And the more time that has passed, and this is more abnormal, this size of reorganization, it makes it harder and harder and harder for that to be accepted.
Right. And so if you have most of the nodes on the network, and particularly most of the mining power on the network, refusing to take a block that is several hours old, then they're going to keep mining on the same chain that they're already on, and the rest of the network, is going to follow on the path that they were already on, rather than dumping all the work that had already been done and switching over to a new chain.
Interesting. So first of all, this idea, I remember when you guys were posting about it on Twitter, I saw Vitalik kind of like respond. It sounded like he was part of the process. What was his involvement in this?
So, and Isaac, feel free to chime in. I don't want to walk all over this, but
yeah, you're doing great.
So Isaac was doing some research into, actually it was Luke, wasn't it? Was doing some research into different solutions to 51% attack problems, and actually found a post Vitalik had made on some message board back in 2016 about this modified exponential subjective scoring. And so we kind of took that and made a few tweaks to it. We chose a different finality curve that levels off over time rather than continuing to get exponentially more difficult. But this is based on an idea that Vitalik floated a long time ago, and then he actually came in and reviewed our specification for it, and had a couple of inputs, and so we actually changed the curve again based on Vitalik's input to be something that's a little bit easier to stand over in a multi-client situation where you've got different implementations, making sure that every client can be on the same page a little bit more easily.
That's pretty cool, right? That you can like go through antiquity of like blockchain information discussions forums, find something from 2016, and then work with the person who ideated it back then.
Especially for such a big name as his.
Yeah. So and that now, from my understanding, the curve change was a big deal in that that's what prevents the network from bifurcating. So kind of weirdness.
Yes. So what we call the finality curve is basically how it's a mathematical expression that represents how much harder an attacker who's bringing a new chain to the network, how much harder that has to be than the chain you're already on. And so the original curve that we started out with was an exponential curve, and it just got harder and harder and harder and harder.
Which means like some nodes would never just come back. They would.
Right. Yeah. And yeah, the problem with that was that if it just kept getting harder and harder and harder and harder, then you could end up in some situations where, the example Isaac and I have been using throughout the development of all of this is like, imagine that some fiber optic cable going to Australia gets cut, and Australia has been cut off from the internet, and it gets fixed after 5 or 6 hours, right? But for a while, Australia still had its own little network, its own little version of the internet. It just couldn't connect to Asia, couldn't connect to Europe, couldn't connect to North America. So its nodes were sitting there, mining on their own. Well, in the exponential version of this, they never resolve that because they see at this point you've got two honest chains. You've got the Australia chain and the rest of the network chain. It's not necessarily an attack, but you have these two chains that can't get back onto the same page, and the Australia chain is rejecting the rest of the world chain, and the rest of the world chain is rejecting the Australia chain without intervention, which, as a practical matter, intervention can happen. Australia is going to realize that they were disconnected from the internet, and they're going to take some action.
Yeah, I think somebody would figure that out.
But essentially at that point, those nodes would almost have to rebuild resync their nodes from scratch. Whereas with the curve that we have that goes up fairly quickly and then flattens off after a certain number of hours, eventually after a long enough time of the rest of the world chains being enough stronger than the Australia chain, the nodes in Australia will go, okay, well, the rest of the world has overcome that finality curve, so we're going to switch over to that, and the nodes will handle it automatically, even if nobody's paying attention. And that would not have been true if we just kept the exponential curve going up and up and up
the whole time. So in your testing, it was having, like, preventing the 51% attack harder? Was that the thing you had to focus on, or was it some of these edge case?
So
like, we can stop 51% attacks, but making sure that the network's always able to come back together and, you know, operate kind of
right. So really, it's kind of a balance of several concerns. I mean, you know, first of all, we want a distributed network. Like, you know, we could go, you know, make a chain like Goerli or Rinkeby or Kadi and have, you know, a proof of authority chain where you've got 7 people who decide what goes in and what doesn't. But I mean, that doesn't align with the community values at all. You know, then there's other considerations of yes, we want to prevent 51% attacks, but we don't want to do so in a way that's going to give an attacker a way to bifurcate the network, kind of like the Australia scenario, but from an attack. Like, we don't want to give them an easy way to split people off and say, you know, this group's going to go over here and they're going to refuse to join back with this group over here. And several of the scenarios that we considered had what we called edge of eternity attack vectors, where, you know, there is one block where if the attacker can split people at just the right time, you know, they mined all of these blocks, they dump them on the network at exactly the right time. Half the nodes get this one, half the nodes get that one, and you have 2 network segments that without intervention will never rejoin. And so we wanted to make sure that we avoided those, and MES was really a, you know, it threaded that needle very nicely. It increases the attack cost for an attacker, you know, by an order of magnitude, while still, you know, it can create periods of time where you have bifurcated networks, but it's never a situation where the network can never come back together on its own. So you know, if somebody wants to spend enough attack power, they can, for a period of time, split off the network and have, you know, some people over here and some people over here, but they have to maintain that at a very high cost to them.
Right, and so there were multiple things to solve for, and it wasn't only, hey, preventing 51% attacks, because, you know, we've discussed this before. You could switch over to proof of authority, as you said. That's been figured out, that's been done. Why is it, you know, ETC has such a strong value system connected to proof of work?
Isaac, do you want to take that one?
Oh, it's what makes Ethereum Classic, I think. From Ethereum Classic's birth, back at the DAO hard fork, it was about making a decision about core values and protocol integrity, and then being willing to follow those values. And part of that value system is proof of work.
And you know, to kind of speak to why part of that value system of proof of work is that, you know, anybody can participate in proof of work. It's not something that, you know, if you've got, you know, fairly standard computer hardware, you can start mining, you can find blocks, and it's not some, you know, there are certainly organizations with more hashing power than other organizations or other individuals, but anybody can come in, you know, either start small and, you know, join a pool or mine on their own, make a big investment. Anybody can get involved with proof of work. It's not, it's a permissionless system. Nobody has to say, yeah, you're welcome to come, you know, start participating in this process. You know, when you get into something like proof of stake, and I mean, you know, my business is involved in some proof of stake systems as well, and there's value there, but you've got to start off with some of whatever token is being staked, and so where do you get that? You've got to get it from somebody who has already got it. So you've got to get it from somebody who already has a stake, and why are they going to share that with you? And what have you got to give them in order to start getting involved with proof of work? You might have to go buy a graphics card, but you don't have to get that graphics card from anybody who's associated with the network. It's a completely permissionless entry to the network.
Yeah, and I think you guys both said it perfectly, which it's part of the identity of Ethereum Classic. I mean, going back to the creation of Ethereum Classic, it's always been connected to values a bit more than a specific technology stack. So understanding that that proof of work is important. Whenever I try to explain to people why. I mean, ETC is second only to BTC. I mean, for me, those are the two that I only care about. And that's because Ethereum Classic has the Bitcoin store value, and it has Ethereum's usability kind of production of value. Now with MES, I understand how the store of value, the same way that Bitcoin is structured, where we can go and keep that safer now. Does anything change on the way it acts as a EVM, as a value producer, as a usability? What changes on the usability side now that MES is going to act?
From a developer's perspective, not much has changed. I mean, you can deploy contracts. You can if you are an exchange or somebody who's selling off-chain goods for on-chain properties, there's now a fairly concise formula that you can apply to determine how long you need to wait before that transaction that happened on-chain is final enough for you to do something off-chain. So if you're an online exchange and somebody wants to send you ETC and trade it for Bitcoin, for the past couple of months since the 51% attacks have started, those Bitcoin, that transaction was very risky for the exchange. That they could potentially accept the ETC only to have that transaction reorged out, and they've already given away the BTC. So with MES, it becomes exponentially more expensive as time goes on, up to a point, for an attacker to conduct an attack. And you would need, to conduct a 12-hour attack, you would need a level of hashing power that's closer to what the Ethereum blockchain has than what the Ethereum Classic blockchain has.
Yeah, which basically means it's not happening. I mean,
right, yeah. If you could conduct a 51% attack on that, you might as well just go a little bit further and conduct a 51% attack on Ethereum that hasn't implemented MES. So
now, so from what I understand, MES really is going to allow the usability to come back online, which
right.
is confirmation times go down. Mining rewards are secure. So the usability of Ethereum Classic comes back. And after Isaac, this is a good question for you. After Atlantis and Phoenix, these hard forks that happened last year and earlier this year, is there any feature or technical difference on what contracts could work on Ethereum versus Ethereum Classic? Like, could we start having the DeFi boom that's on Ethereum happen in Ethereum Classic now that 51% attacks are no longer an issue?
Yeah, absolutely. The protocols from an EVM perspective and from the developer and dApp utility perspective are exactly equivalent. So if it can happen on Ethereum, it can happen on Ethereum Classic.
And like I keep telling people, this is the silver bullet right here. Because I mean, I don't know about you guys, how much you've done DeFi. I've been wrapping different things. You know, I've got my urine and my curve, and you know how much I'm paying for these transactions? It's like $100, $200. Imagine, imagine if all of that came to ETC.
Right. Well, and you know, so as you mentioned at the beginning of the call, you know, my company is OpenRelay. We have a product called Rivet, which is a Ethereum gateway. We offer node connectivity to Ethereum, Ethereum Classic, and a bunch of different test nets. We made the decision back in June or July, launched in July, to support Ethereum Classic, specifically because Ethereum was getting incredibly expensive to operate on. And, you know, while there's still reasons I think Ethereum will continue to be, you know, the dominant chain for DeFi, and that's mainly because that's where everything's already happening. And
Right.
So, you know, you've got all of these assets on Ethereum that you can collateralize on the Ethereum blockchain, and, you know, moving those to Ethereum Classic. I know there are some bridges between the two chains, but you know, at the end of the day, you know, there's a lot of inertia over there for, you know, you've got all of this value and stuff can get locked there, and, you know, I think that's fine. The thing that really had me excited about coming along for Rivet to support Ethereum Classic is really a lot of the other opportunities that, you know, permissionless games, permissionless, you know, art, all of these other things. You know, there were people developing projects on Ethereum back when gas was cheap to, you know, tokenize their artwork and sell NFTs that represent this piece of art. And at $50 a transaction, that's got to be some pretty valuable art.
Yeah.
On ETC, you know, you're still talking pennies a transaction. And that's what we were really hoping to help drive by adding support for Ethereum Classic to Rivet, was that, you know, give those projects that just don't have the dollar value behind them to justify $50 transactions an opportunity to, or you know, a place that they could easily go and you know, move those projects, you know, lift and shift, because it's, you know, the exact same EVM, take them over to Ethereum Classic, and, you know, you've got your project up and running on, you know, still a permissionless blockchain, and now that we have MES in place, ideally a nice and secure blockchain.
Right, because without MES, without that stability, I mean, it sounds like it was almost virtually impossible to see the DeFi craze or the NFT boom happen until that was solved.
Yes. Well, and I mean, so a lot of people weren't very aware of the level of risk of a 51% attack that Ethereum Classic faced. That, you know, there was a 51% attack, what, last December, something like that. But, you know, but then it kind of went away, out of sight, out of mind, and you know, nobody was all that worried about it. But, you know, I think, and you know, ideally we would get back to a situation where Ethereum Classic doesn't need MES. That ideally you just have the hashing power that, you know, there's no way any individual entity is going to be able to buy enough hashing power to overpower that. But you know, the problem with that is, you know, once you get into this cycle of 51% attacks, you know, exchanges don't want to let you take, you know, just take your ETC and let you trade it for other things. And then if miners can't take their ETC to exchanges, they're not going to mine, so the hashing power falls further, and you just get into this cycle where it's easier to attack. Exchanges are less comfortable, and so really my hope is that MES will serve as a reset for that. That it, you know, it gives the network enough security to you know, regain the confidence of exchanges, which gives it the ability to regain the confidence of miners, which gives it the ability to lift up the amount of hashing power to the point where, mess is never going to come into play because nobody can come up with that much hashing power.
Yeah, don't mess with ETC. That's gonna be the motto. Come on, you want to try? Don't mess with ETC. Look, you're right. Another attack had happened a year ago, and if you kind of look at this trajectory of also kind of looking at the hard fork work, there's never been a point where the parity of capabilities with Ethereum existed, and there was no 51% attacks happening. So the last year, development-wise, was getting to that parity. Am I correct on this, Isaac?
Yeah. Yep. Yeah. Working through the hard forks and implementing the opcode so that the contracts can run the same.
So if like there was just a very small time where like ETC had all the capabilities of Ethereum and wasn't in the middle of, you know, this vicious cycle of attacks, which put so much downward pressure on price, right? Because of obvious things. You can no longer have the market exchange, you know, rapid trading, and then you lose the confidence on the miner side because you can't get the mining rewards. You know how many miners are like thrilled that this is coming? I talk like every single one is just like, when can I update? When can I update? When can I update? And the moment that hits, hash rate goes up, right? Then confidence goes back up, just like you said. And it's almost like a slingshot effect. Everything goes back to where it was. But now we're in the middle of this new boom of NFTs and DeFi, which is really supported on the Ethereum network. And here we are, the silver bullet. A lot of people don't know, the best kept secret. We've got all of the capabilities, lower transactions, and now no longer this 51% thing. I'm telling you, it was like the number one thing people knew about ETC like 2 years ago, which is just, it's unfair.
Yeah, and I think it's also worth pointing out that these challenges that Ethereum Classic has faced, you know, this year with the 51% attacks, these are natural functions and natural vulnerabilities for any proof of work chain that isn't the biggest in its domain. So if you're Ethereum and you're Bitcoin, there are vulnerabilities, no doubt, specifically, for example, in collusion. But if you're not them and you're a proof of work chain that isn't the biggest, those chains are in the exact same position that Ethereum Classic is in terms of being vulnerable to these kinds of attacks. So we're hoping with this solution that we can publish this and open this as an opportunity for chains that are in a similar position to Ethereum Classic to have in their toolbox in case this becomes an issue, and to act preventatively.
It's a very good point.
To share this technology with.
That's a very good point.
That's very, that is a good point. And yeah, I would love to see, you know, some of the other small chains out there, or smaller proof of work chains that, you know, are maybe not encountering, but worried about 51% attacks. You know, I think MESS is a great, fairly low overhead solution. You know, it's what you can call a soft fork, in that not everybody has to adopt it. If you just get, you know, enough miners to adopt it, the blocks that it produces will still be considered valid by everybody else. They're just going to reject blocks under certain scenarios. So, you know, it's something that you don't even necessarily have to have full community support for. You don't even necessarily have to have community leadership support for. If you get enough miners who decide, yeah, we're going to build a client with MESS, they can do that.
Yeah, and that's the power of decentralization too, right? And what's very funny about market caps of coins, I was looking at it the other day. It's the proof of work is not like, it's hard to do. There's very few proof of work coins that are like significant. Like the top two, we always talk about Bitcoin and Ethereum. Those are both proof of work. Ethereum, you know, I believe has aspirations for proof of stake, of course. But after that, there's not much, it's all either iterations of Bitcoin or, like Dash maybe is kind of a proof of work. And then like everybody else is, further down on the market cap, like a Zcash or a Monero. It's very telling that proof of work is the superior value preserving security choice. So the fact that we were able to solve this, it really is a big deal, and it would be amazing to see some of the other chains consider adopting it if they're in this similar secondary hash rate position. Yeah, that was my my big verbose sentence there to show I understand the technology. And I think what I want to also understand, Austin, because without OpenRelay, a lot of this testing wouldn't have happened, and I'm sure the entire Ethereum community is very thankful for that. What do you think the future between OpenRelay and ETC is? Because as you said, you chose ETC because of these low transactions, and now there's also the NFTs, as you mentioned. Where do you see OpenRelay kind of growing in ETC?
OpenRelay is a blockchain infrastructure provider, and we kind of specialize on EVM related things, which made ETC easy for us to pick up. We're not necessarily going to stop there, but I do think that as ETC becomes stabilizes a bit after mass adoption, and you start to get back to the point where you can buy ETC on an exchange and get it the same day instead of having to wait for 5,000 block confirmations or whatever they're doing these days.
Not for long. Not for long.
Yeah, that's the hope, right? And I mean, really, it's up to the exchanges and how convinced are they that this is going to solve their problems.
They're not going to want to miss out. That's what's going to happen.
Right.
The moment it's shown that like you guys have done so much testing, and the report you shared earlier with me, I'm working on getting an article out so everybody can really understand how rigorous the testing was.
Right.
You're not going to be the one exchange not offering ETC when
right.
Like once the action starts, everybody wants to be part of it.
But yeah, I mean, we've got a fairly significant social media presence. We're going to put our weight behind getting projects that have been priced out of operating on Ethereum to take a look at Ethereum Classic and realize that it is a viable solution. We've got viable infrastructure.
And I like the way you said it. Was it left and shift? How did you say it?
Lift and shift. That's a term like, if you've been running your own data center and you want to move to AWS or Google Cloud Platform, they call that a lift and shift. You take the servers that you were running locally, you move them into the cloud, and you continue operating the way that you were. And in practice, a lift and shift from local infrastructure to cloud infrastructure never goes smoothly. But there's if you don't have big entanglements with the rest of the Ethereum community, like a lot of DeFi is very intertwined, where DAI is dependent on ETH and ZRX and BAT and all of these other coins that you can collateralize, and then Comp is dependent on DAI, all of these other, it's going to be hard for them to lift and shift. But if you've got a little art project where you're selling the art that you've done as non-fungible tokens, and you might take DAI as the token that you sell them for, but if you're not deeply intertwined with all of that, the stuff going on on Ethereum DeFi, taking your contract and moving it over to Ethereum Classic should be pretty darn straightforward. And we've got a series of tutorials that we're putting together, just broadly for how to run, different types of applications with Rivet. And I'm sure that part of that tutorial series will talk about Ethereum Classic as an option, and how those projects can leverage Ethereum Classic for lower fees and stuff like that.
So thank you so much for discussing MESS with us today, Isaac, Austin. Again, thank you again for your contributions to making mess happen. I'm super excited to see it. And ETC world, we're coming back, baby. Thanks for the time, guys.
Thanks,
you,
Dean.